Hello friends, in this video I'd like to solve the following crazy looking problem from the Irish Mathematical Olympiad 2016, problem number 9. We wish to show that this number, which I don't even try to read out loud, this number is in fact an integer and you find its value. So first of all, my hints for this problem. First of all, do not panic. It's not that difficult. Maybe it is difficult, but it's not tragic. My main hint is, for the sake of brevity, make the following substitution or define the following variables or constants. Let a be the cube root of 252 and let b be equal 5 times the cube root of 2. And then compute the product a times b and the sum or difference of cubes of a cubed and b cubed. And finally, the following identity, the following factorization will be helpful. A cubed plus or minus b cubed is a plus or minus b times a squared minus or plus ab plus b squared. We'll give this problem a try and I will see you in a minute. Okay, so I hope that you've managed to solve this problem. As I suggested, set or let maybe better word, let a be equal to the cube root of 252 and let b be equal 5 times the cube root of 2. Let's do the factorization of these numbers. The second will be easier. It's the cube root of 250. It's 250, but let's write it as 2 times 5 cubed. And the first factorization, after some calculation, it's 2 to the second power times 3 to the second power times 7, I believe. Okay. And now let's compute a times b, a cubed plus b cubed, and a cubed minus b cubed. Let's start with the first one. A times b will be the cube root of 2 to the second power times 2 will be 2 to the third power. Then we will have 3 to the second power, 5 cubed, and we'll have 7. And we can write it as 2 times 5 times the cube root of 9 times 7, and that's just 10 cube roots of 63. Would you look at that? The exact same number appears right here. What a coincidence. So these numbers, here we have a, here we have b, a, b, and a times b. Okay. Then a cubed plus b cubed is 252 plus 250, which is 502. A cubed minus b cubed is 252 minus 250, which is just 2. Okay. Now let's tackle our crazy looking expression. I have prepared it in advance. Let's play with it. So the first fraction will have 251 in the numerator, and here we have 1 over a minus b, and this number, as we have just established, is a times b. And the second fraction is 251 a plus b plus a times b. Okay, that looks somewhat nicer. And now let's do the following trick, you can say. Let's do the following trick. I will take these fractions in the denominator and I will do the following. in the first fraction, I will multiply the numerator and the denominator by a squared plus ab plus b squared. Let's move it a little bit. Okay, and here I will multiply by a squared minus ab plus b squared. Okay, I have done that to complete the difference or the sum of cubes. And here I have numerator 1. Okay, and now let's see what we get. 251. And in the denominator, we have a squared plus ab plus b squared over a cubed minus b cubed minus a times b. Here we have 1 over 251 times a squared minus ab plus b squared over a cubed plus b cubed plus ab. Very well. And now let's do the following. Here we have 251, and recall that a cubed minus b cubed was just 2. We have 2, and here we have a squared plus ab plus b squared. And here let's write minus 2 times ab over 2, because I will have a common denominator in a moment. And here I have the following: a cubed plus b cubed, it's just 2 times 251. Why? Here it is. 502 is 2 times 251. And here we have 2ab over 2. Okay. Now, what can we do? First of all, this number 2, which is here and here, will appear in the numerator. Similarly, here. And also, 251 will cancel with this occurrence of 251. And we will have a squared minus ab plus b squared, and here we will have a squared plus ab plus b squared. All right. And now I will do one more trick, again completing the cubes. So here I have 2 times 251. Here I have 2, and I will do the following. I will multiply here by a plus b, and here by a minus b. Why? Well, let me write everything, and I will talk. Well, after doing that, we have the following. 2 times 251 times a plus b, and here I have a cubed minus plus b cubed, and here I have 2 times a minus b, a cubed plus b cubed. Okay, nice. And now let's recall one last time that a cubed plus b cubed is 2 times 251, and sorry, there should be a minus, my bad, and a cubed minus b cubed was just 2. After reducing by 2 and by 251, we get a plus b plus a minus b, which is 2 times a. Wow, would you look at that? And a, recall that it was the cube root of 252. Okay. Remember that that is just the sum of my fractions. In our original problem, there is also cube, third power right there. So I just have to raise my result to the third power. And I will get, after raising it to the third power, I will just get 8 times 252, and that just happens to be 2016, which is clearly an integer. So that concludes our proof, that concludes our video. Quite a challenge, don't you think? In these types of problems, they appear quite rarely on mathematical Olympiads, but it's often beneficial to consider naming some numbers like a and b, and looking for their product or sum of powers or something like that. That usually makes life much easier. Thank you for watching. Again, our result is 2016. I will see you next time. Goodbye.